In space, there are remnants, cosmic fossils, some that remain from almost the beginning of time. These ancient fossils exist as cosmic background radiation, and at NASA, they developed a unique satellite to probe the cosmic radiation as a key to unlock the mysteries of the early evolution of the universe. Scientists believe that in the beginning our universe was very smooth and hot, uniformly filled with matter and radiation. But as the universe cooled and expanded, it evolved into what we see today, irregular and lumpy, and filled with galaxies and clusters of galaxies. Scientists are studying the background cosmic radiation, but this radiation has grown extremely cold and faint as the universe has expanded. So cold and faint that Earth's warm blanket of atmosphere obscures it, making it impossible to study from the ground. NASA's Goddard Space Flight Center worked with universities and industry to develop the Cosmic Background Explorer, Cobe. Getting above our obscuring atmosphere is only the first step. The radiation itself is difficult to detect. This is because as it's cooled for billions of years, it's grown fainter and shifted to the long wavelength portion of the electromagnetic spectrum. The radiation is now so cold that it appears in the microwave and infrared regions of the spectrum. Sensitive detectors for these wavelengths have only recently been developed. For Cobe, instrument designers push this technology to the limit. The satellite's 3 instruments are extremely precise and very sensitive to infrared and microwave radiation. The instruments also have to be supercooled so that their own heat doesn't overpower the cold radiation they're trying to detect. One cosmic remnant is now so cold it radiates at only 3 degrees above absolute zero. Launched by a Delta rocket from Vandenberg Air Base in California, Cobe is placed in its orbit 560 miles above Earth. The satellite begins a controlled spin and deploys its thermal shield solar arrays and antenna. About a week later, it ejects its protective cover to begin its mission, to search for the missing link in cosmic evolution. To keep certain that instruments are even colder, chilled to 2 degrees above absolute zero, engineers enclose them in a very sophisticated thermos bottle. But meeting this challenge raised another: to build systems with moving parts that can operate at such a low temperature for more than a year required very specialized engineering techniques. With development and testing completed, 3 instruments are integrated into a satellite that is the culmination of 25 years of work to develop and refine instruments that can detect the remnant radiation from the early universe. With Cobe, scientists will study the microwave and infrared cosmic background radiation, 2 cosmic remnants that may reveal how our once smooth universe evolved into the wondrous variety of the cosmos. Engineers at Surrey Satellite Technology have spent over 20 years building small Earth observation satellites for a variety of countries. This idea is to put a constellation of satellites, each smaller than a fridge, into orbit around the Earth to help emergency services and relief teams respond better to natural disasters. 6 countries are involved, each building its own satellite at Surrey. Algerian engineers are putting the finishing touches to their spacecraft, ALSAT-1. Conventional satellites pass a particular point on Earth only every few days. The network of small satellites in low orbit, however, can beam back constantly updated images of an unfolding disaster, like this Mekong River flood in Cambodia from September 2000. The advantages of small satellites is that they can be manufactured much more quickly and much cheaper. Therefore, they can simply afford to put more of them into orbit. This project will be called the Disaster Monitoring Constellation. This is the view from the space shuttle above the Earth. Right there is the Kennedy Space Center in the state of Florida, USA, where shuttles are launched. This high perspective allows the astronauts to know exactly where they are. As the world's longest mountain range, the jagged line of the Andes frames the entire western side of South America. Many of the mountains here are active volcanoes. The lava they spew builds up the land while glaciers and rainfall tear the land away. On the eastern side of South America and Brazil lies the vast Amazon rainforest, home to millions of species of animals and plants. The world's second largest continent, Africa, is next. As we fly over, the differences in the climate are easy to detect. On either side of the forest band lay the savannas. In the northern savanna range, space photography shows how natural changes have affected Lake Chad. Beyond the savannas, great deserts like the Sahara in northern Africa and the Kalahari in the mid and south consist of barren, rocky flats and wind-formed sand dunes. And there is the Nile River, the longest river in the world. Now we're passing over Europe and the Iberian Peninsula, where Columbus set sail to search for a water route to India. North of Italy, we can see the elegant arc of the Alps through France, Italy, Switzerland, Germany and Austria. The narrow Strait of Gibraltar. Spain is to the north, while Africa is to the south. The border between Europe and Asia, the largest inland sea, the salty Caspian Sea. Moving northeast into Siberia, we encounter the comma shape of Lake Baikal. This enormous lake, the world's deepest, contains about 20% of all the world's fresh water. Far away are the snow-capped Himalayas in India and Pakistan, home to the highest mountain on Earth, Mount Everest. One more glimpse of Asia shows us the Sinai Peninsula with the Red Sea, the Gulf of Aqaba, the Gulf of Suez, and the Mediterranean Sea. Onto the land down under, Australia, the smallest continent. The red that you see is the result of high iron content in the soil. To Australia's east lies the vast Pacific Ocean. It will take us about 20 minutes to cross the Pacific, even though we're travelling at about 8 kilometres per second. As we pass over the Pacific, we see Hawaii, one of the many islands that dot these immense waters. North America's next, the San Andreas Fault that stretches almost 1,000 kilometres from Mexico through most of California, and is of course the cause of frequent earthquakes in this part of the world. The state of Utah is home to the Great Salt Lake. The visible line is a railway causeway that interrupts the water's circulation, causing one side of the lake to be saltier than the other. On the east coast is Long Island, New York, formed a long time ago by a glacier. But not all of Earth's sites fulfill our expectations when seen from space. A geological wonder like the Grand Canyon in Arizona looks like a series of uninteresting lines from orbit, dramatically showing us how difficult it is to perceive depth from outer space. The only continent we didn't cover is, of course, Antarctica. because the shuttle doesn't travel that far south. Huge plumes of electrified gas pour into space from the Sun at over 3 million kilometers per hour. These periodic flare-ups of solar activity can affect weather patterns on Earth, knock out power systems and satellites. Solar physicist Professor Richard Harrison is working on a space program to image these violent gas clouds from the Sun. This is SOHO, the European space-based observatory that has been monitoring the Sun from space since 1995. But it can only see with one eye. The stereo mission will consist of 2 satellites in space, giving a more rounded picture of the Sun. The stereo mission should help provide advanced warning of solar storms impacting the Earth and greatly improve our understanding of the workings of our own star. Nigel Packham is a researcher at the Johnson Space Centre. He will spend the next 15 days in this small airtight chamber. The experiment will test for ways to make breathable air where none previously existed, and at the same time testing the capacity of plants to live off the expelled air from people living in close proximity. This experiment is part of the search to create a regenerative life support system for use in space. An essential part of this experiment was to examine the interaction between man and plant. Because not only do you need air to breathe, your food needs its air too. One without the other would eventually result in the death of both. The airtight chamber that Nigel currently calls home is 9 foot by 9 foot. All the amenities of life are in there with him, including computers, phones, emails, and an exercise machine. The purpose of the experiment requires Nigel to live a basically normal life while in the chamber, doing all the things that would normally be done by people living and working away from natural self-generating sources of air. The airlock which houses Nigel, all his work equipment and personal objects, is attached via a soundproof door to a chamber which houses a variety of wheatgrasses. The rooms are connected by passages which circulate the flow of air from one room to the other and back. Using the age-old process of photosynthesis, the plants will provide oxygen to Nigel and simultaneously remove carbon dioxide from the air. Carbon dioxide produced in increased amounts, particularly during strenuous exercise necessary for the long-term fitness of astronauts, would result in a toxic buildup of CO2 unless breathed in by the plants. The wheat growth chamber requires about as much area to house its 8 baths of wheatgrass as Nigel does to live. It is a fairly high space requirement in a generally space-conscious world. This seemingly simple experiment could provide a vital ingredient for the long-term survival of man in space. The wheatgrass is grown in several stacked hydroponic baths under the constant light of 3 high-pressure sodium lamps. They can grow a full cycle from seed to harvest in about 90 days, providing fresh air and food along the way. On the occasions that he enters the wheat growth chamber, Nigel describes it as literally a breath of fresh air. The plants have reacted very well to using Nigel's expelled air and react quickly to changes in his metabolic output. When he exercises, it's like feast time for the plants. Nigel describes it as if the plants know he's there. The experiment, successfully concluded, proved the viability of air regeneration through the interaction of man and plant. However, once the experiment ends, the real work begins. analysing the data. Nigel will now be thoroughly tested to see how his body has reacted to the artificial conditions and the reliance of his body on a single source of oxygen for 15 days. By looking at ways to create a regenerative life support system capable of maintaining itself and a range of humans living together, NASA have designed the ultimate in future homes. An organic technology hybrid which provides not just shelter, but air and food as well. At the Open University in Milton Keynes, home to the Planetary and Space Sciences Research Institute, some of the world's top scientists dedicate their lives to uncovering the secrets of the universe. But finding the answers to some of the big questions means carrying out years of investigation, often spanning over a number of decades. Studying comets, for example, requires long space missions, meaning several generations of researchers are involved. Scientists spend their time unravelling information brought back to Earth from European Space Agency missions. 65-year-old Tony McConnell, a specialist in the field of cosmic dust, is giving a seminar at the Institute. In the 80s, McConnell took part in the first European comet mission. His team studied the impact of cosmic dust from Halley's Comet, using information gathered by the Giotto probe in March 1986. The data collected attracted young researchers like John Zanicki and later Neil McBride. McDonald says it's a fact of life in space research that you don't always reap the rewards of your work. Zanicki is now looking at material from the Cassini-Huygens spacecraft and getting information for the European Space Agency's Rosetta launch. When Rosetta launched, scientists knew they would have to wait 10 years before the comet chaser obtained any data. Zanicki says it's a case of accepting your place in the scheme of things. Much of Zanicki's research will be followed by scientists like Neil McBride. McBride says that continuity in research is essential. After 6.5 years of travelling, the Cassini-Huygens spacecraft began its orbit of Saturn. Following in the path of Voyager, it will continue to provide vital information to generations of scientists, past, present, and future. In the pre-dawn calm of July 15, 1975, this would be the last flight of the Apollo Saturn mission. As the countdown narrowed, chances are that more than one member of the launch team reflected on the proud days of Apollo. It's 9 flights to the moon, 6 of which resulted in landing men there. It's 3 flights to Skylab, transporting crews to the orbiting space station. And now, in 9 days, the entire Apollo program would pass into history. Apollo would make way for a 2-way reusable vehicle, the Space Shuttle, scheduled for its orbital flight debut in 1979. But today, it's Apollo-Soyuz, and as dawn approaches the Florida coast, a similar drama is nearing climax half a world away. The scene? Baikonur Launch Complex in Kazakhstan, central USSR. At Mission Control Moscow, flight controllers monitor Soyuz as it gathers momentum en route to orbital altitude. Less than 9 minutes after launch, Soyuz, powered by triple booster stages, is inserted into its assigned orbit. A near-perfect day for the launch, made to order for the thousands lining the roadsides and beaches in order to witness this Apollo Saturn finale.
Three, two, engine sequence start. 1, 0, launch commit. We have a liftoff. All engines building up thrust. Moving out. Clear the tower.
Roger, tower clear. Roger, Tom, you got good thrust on all engines here, right on the money. 1 Bravo. 1 Bravo, search Roger, go for station.
Before the flight is 3 hours old, the docking module is smoothly extracted from the second stage booster left trailing behind. During the next 40 hours, Apollo, through a series of maneuvers, will slowly close the orbital gap with Soyuz. The two crews will meet again, not as members of this or that nationality, but as friends who for 3 years shared their separate cultures and customs and a part of themselves. In preparing for their missions, Soviet and American crews spent a good deal of time together. The building of the first universal docking system constituted the specific goal of the Soviet-American Space Agreement signed in Moscow in 1972 by the chief executives of both nations. Although each nation designed and built its own half of the docking system, the interface, that is the physical making of the two, was a single design. Considering the language barrier, the differing technologies, two diverse political systems, the development program moved with relative ease. There were differences to be sure, but none that was above negotiation and compromise. Around the world, millions watched and listened as the two spacecraft became one. They are counting down the hours at the European Space Center in Germany. They are tracking the Huygens space probe. Huygens has spent many years riding the Cassini spacecraft which arrived at the ringed planet a few years ago. British scientists and researchers have been an integral part of the European team for this operation. The probe's plunge into Titan's thick atmosphere should be one of the mission's major highlights. The major objective of the probe mission is to measure all the properties of Titan's atmosphere, make sure that we understand the behavior of the atmosphere, and also make some remote sensing in terms to taking pictures of the surface itself. When the probe hits the top of Titan's atmosphere, there will be friction on the heat shield, and parachutes will slow the robotic laboratory's descent. All this time, the equipment will transmit information back to Earth. Finding life on Titan is highly unlikely, but nonetheless the European experiment should return valuable information on the atmosphere's composition, structure, temperature, pressure, and winds.